SIERA Energy Resources Limited is the largest wholly owned indigenous independent power developer in Sierra Leone and was formed to address the growing electricity demand in Sierra Leone and in response to the government's invitation for private sector involvement in power sector projects. SIERA is currently developing the 27-megawatt Betmai Run of River hydroelectric project, which will have a positive social and environmental impact and power Sierra Leone's economic growth. The Betmai project has been progressively developed and studied for over 9 years through 3 separate studies. The first study was completed in 2011 by Knight Piasold, an international engineering and environmental company with over 98 years of hydropower experience. The second study was completed in 2017 by Midgard Consulting, a Vancouver-based engineering company, to collect additional hydraulic, geologic, and topographic data, as well as build on the previous designs and focus on securing the necessary permits, water and land rights, and power purchase agreement. The third and current study is being completed by Knight Piasold under a United States Trade and Development Agency financial assistance grant to optimize the facility designs to meet international best practices, identify potential equity and debt sources, progress implementation plans and contracting strategies, and support the development of the environmental and social impact assessment to IFC performance standards. SIERA is committed to the sustainable economic, social, and environmental development of Sierra Leone and local communities in particular, having already invested in the construction and of a local school for nearby villages. Sub-Saharan Africa's opportunities are vast, and its challenges persistent. Home to the world's largest free trade area and a 1.2 billion person market, the continent is poised to create an entirely new development path harnessing the potential of its resources and people. The sustainable and development of power and renewable energy in particular will help Africa reach its full growth and innovation potential and lift 416 million Africans out of extreme poverty. Sierra Leone covers an area of 72,300 square kilometers and is home to approximately 7.6 million people, of which only 10% to 12% of the urban population and 2% of the rural propulsion have access to reliable electricity. Sierra Leone currently has an operating capacity of less than 150 megawatts of power, of which 99 megawatts are from renewable sources, with hydropower making up 61 megawatts. Once implemented, the Betmai hydroelectric project will increase Sierra Leone's hydropower capacity by 44% and the overall operating capacity by 18%. Making a significant contribution in addressing Sierra Leone's power needs. Sierra Leone has a great hydropower potential with estimates ranging from 2,000 megawatts to 5,000 megawatts. In 2018, IRENA estimated that there was 749 megawatts capacity in identified projects. The Betmai project is a 27-megawatt run-of-river hydropower facility located on the Pampana River, approximately 40 kilometers east-southeast of the city of Malcari and 12 kilometers north of the town of Makalai in the northern province. The intake system is located approximately 500 meters upstream of the Betmai Falls and is approximately 77 meters above the powerhouse. The intake system is designed using international best practices to maximize efficiency and minimize the overall footprint and upstream inundated area, which has environmental, social, and construction benefits. This includes a non-overflow section adjacent to the right abutment to contain the head pond, an 8-meter-long and 4-meter-high metal-clad inflatable rubber wear section to manage and control various flood return events up to the 1,000-year return event. During flooding, the gates will automatically be lowered to pass the excess flows downstream. In a lowered position, the gates will be in a horizontal position. Two identical flushing gates located on the left-hand side of the inflatable weir to flush built-up sediments in front of the weir and intake structure respectively. An intake structure is located on the left-hand abutment to divert up to 40 cubic meters of water into the power canal. The intake forebay includes an elevated intake section, which is fronted by a grouted riprap apron, coarse trash rack, and scour channel to mitigate the intake of sediments and debris. The intake forebay splits into two bays, each with a secondary fine trash rack additional protection, control gate to throttle flows, and with a set of stop logs for maintenance. Access to the intake is adjacent to the power canal on the right bank and terminates in a parking, storage, and laydown area located on the left-hand side of the intake. A 1,237-meter-long trapezoidal power canal will convey up to 40 cubic meters per second from the intake to the forebay following the natural terrain. The canal bottom will be cut in rock to mitigate settlement and cracking, and the side slope angles varied depending on the soil and rock conditions to promote stability and overall safety. The canal has been designed to contain the full flow with excess water discharging back into the head pond, thereby removing the need for a canal side slope spillway and minimizing the overall footprint and environmental and social impact. Additionally, and as part of the environmental mitigation plan, two game exits have been incorporated along the canal alignment. The power canal terminates into forebay designed to slow and steady the flow and provide adequate submergence before transitioning the canal flow into the four pressurized penstocks. The forebay splits in four bays, one for each penstock, and includes trash racks, stop logs for maintenance, isolation gates to isolate each penstock, and a small sluice gate and discharge pipe to dispose accumulated sediments that accumulate in a sunken trench. There are three 2.3-meter diameter welded steel penstocks, each capable of discharging 12 cubic meters to the larger 8.1 megawatt turbines, and one smaller 1.3-meter diameter HDPE steel penstock capable of discharging 4 cubic meters to a smaller 2.7 megawatt turbine. All four penstocks cover water from the forebay to the turbines over a net height of 76 meters over a total length of 240 meters. The penstocks will be buried to minimize the impact to the environment and take advantage of the soil restraining properties and thermal protection. Hydroelectricity will be generated by capturing the kinetic energy in the four pressurized penstocks by pushing on blades, causing the turbine to turn and create mechanical energy. Generators connected to the turbines will convert the mechanical energy into electrical energy, which will then be conducted through transmissions lines to distribute electricity to homes, businesses, schools, and hospitals. Three 8.1 megawatt and one 2.7 megawatt Francis-type turbines have been selected to generate electricity for the BETMI project. Each turbine will include an inlet valve to isolate the turbine when needed. Flows passing through the turbine are discharged back into the Pampana River, completing the run of the river cycle. BETMI project will have a significant and positive impact on the economic growth and sustainability of Sierra Leone. The project will provide hundreds of employment opportunities to locals during the construction and operational periods of the project. SIERA signed the power purchase agreement in 2017 and has secured the environmental and water licenses and land rights for the project area. The project is ready for development and is expected to take 2 years to construct and commission.